Welcome to Numerical Computing in C++. In this video we will talk about data types and basic numerical operations. These are the different data types that are used in C++. We need to explicitly state what kind of data type we're using when we are writing code. A bool is a data type that can be either true or false. So that represents 0 or 1. An integer is simply an integer. An unsigned integer is a non-negative integer. So that's 0, 1, 2, 3, and so on. A double is a real number. And a float is again a real number, but with less precision. So a double is accurate to about 16 decimal digits, and a float is accurate to about 8 digits. And a car is a character. That's a single letter, like A, B, C, D, and so on. The information in the computer memory is stored as a series of zeros and ones. The smallest unit of memory is 1 bit, which holds a 0 or a 1. And 8 bits make 1 byte. The fundamental data types that we described, the integer, double, bool, and so on, are stored in memory that's a whole number of bytes. On current and recent widely used computers and operating systems, the following are the amount of memory that each data type uses. A bool, that's true or false, occupies 1 byte of memory. An integer occupies 4 bytes. An unsigned integer also occupies 4 bytes. A double, which has again 16 digits of accuracy, that occupies around 8 bytes. And a float occupies half of that. It has half the accuracy and occupies half of the memory. That occupies 4 bytes. And a character, 1 letter, occupies 1 byte. There's a set of rules for C++ that's called the C++ standard. This sets out the rules that a compiler should follow when implementing and interpreting C++ code. For integer data types, the standard specifies a minimum amount of storage. And where the C++ standard doesn't specify what should happen, this is said to be implementation defined. You can check the limit of data types by using these commands. So you can include the library limits, and then you can use size of integer to find out what the storage in bytes is for 1 integer. And then you can call a class numeric limits with a template int, and then ask for the maximum and the minimum limit. So let's try that. Here I've coded up these commands. I'm using the library include IOStream to input and output data. So in particular, I'm going to use cout. So I'm going to print data to the screen, and then I'm including the limits library, and I'm including the standard library so that I don't have to type std every time I use cout or end line. So let me run this code and see what happens. So here I'm using Xcode in macOS, and this button will build and run the current code. So right now it's running, it's finished. And although it ran, I didn't see the result. I have to click this button right here to see the output of the console. So let's run it again. Okay, so here we see the results in the console window. So the first one, cout, that's the size of integer. That's 4. So that's the amount of bytes that is taken by an integer. And here we display the minimum and maximum values for an integer. So that's the maximum number that you can represent as an integer. And that's the minimum number that you can represent. And the program ends with code 0. It means everything ran correctly. Okay, so let's discuss some variables. So here in this program, inside my main function, I'm using x to represent a double. In this case, I initialize it with the value 2.4, and I'm using k to represent an integer, and I initialize it to the value 5. The int and double prefixes specify the type of variable that I'm using. When a variable is first named, that is a declaration. So I'm declaring that variable. We can give it a value at the same time when I declare it. That's called initialization. Or you can wait and give it a value later. It's best practice to give it the value at the same time when you declare it, because that's less error prone. So it's good to do that to avoid making use of a variable that has not been given a value, and then your code will give an error when you try to run it or when you try to compile it. Here's an example. I can declare an integer k and give it the value 1, so I'm initializing k and declaring it at the same time. Or an alternative is to declare an integer like h, and then at some point later in the program I can give it a specific value like 2. So here first I declare it and then I initialize it later. The basic arithmetic operators have their usual meaning. So we have plus, minus, star for multiplication, slash for addition, for division. These are known as binary operators because each one takes 2 input numbers to produce a result. So plus adds 2 numbers, minus subtracts a number from another, and so on. Similar to other programming languages, multiplication and division have higher priority or higher precedence than addition and subtraction. So this means that within an expression, multiplication and division are carried out before a plus and a minus. And you can always use round brackets to make the precedence more clear or to change the precedence. So for example, in this case I have 4.8 divided by 2.4 plus 1.3 times 2. So in this case, the program is going to multiply 1.3 times 2. It's also going to divide 4.8 by 2.4. And then it's going to add those 2 results. So that's the same as putting this first division in parentheses, this last multiplication in parentheses, and then adding the 2 results. These operations are different than this. So if I don't want that to be the order, then for example, if I want the addition to happen first, then I can put this in parentheses And then what's going to happen is 4.8 divided by 2.4 plus 1.3. So it's going to add these numbers together. Then 4.2 is going to be divided by this. And then that result is going to be multiplied by 2. So be careful here. 2 is not in the denominator. So first you have a fraction, and then that fraction, 4.8 divided by this parenthesis, that fraction then is multiplied by 2. So be careful with that. If I want 2 to be in the denominator, then I have to use brackets here and put that in parentheses. So I can do 2.4 plus 1.3, multiply that times 2, put that in brackets, and then now the compiler knows that this is in the denominator of the fraction. So it's gonna divide 4.2 by all of this. So first it's gonna do this addition, then the multiplication, and then it's gonna divide 4.8 by this expression in parentheses. In C++, we have certain increment or decrement operators. These are called unary operators, and they change the value of a single variable. That's why they're called unary. The increment or decrement operators, they add or subtract 1. So plus plus adds 1, and minus minus subtracts 1. So if we define an integer k and initialize it to the value 5, if I type k++, it will increase its value by 1. And if I type k minus minus, it's going to decrease its value by 1. So it's going to become 6 or 4 respectively. Plus plus k and minus minus k will accomplish the same thing, but there's a difference, and we'll explain the difference shortly. So the prefix operators plus plus k and minus minus k change the value and then make use of the updated value. On the other hand, the postfix operators k++ and k minus minus change the value, but then they make use of the initial value. So this only makes a difference if it is part of a larger expression. So we'll code this up in a minute, but let me just say that this plus plus is where the name of C++ comes from. So it is C with something added, basically. And what's added is mostly object-oriented programming. Okay, so let's look at these two pieces of code. Here I have an integer h equals 5, and then if I type h++, and I can define another integer m equals h, and I can print m and h and see what happens to it. Or I can do the same, but instead of h, I can have plus plus h. So let's do that and see what happens. Okay, so here I've written this program. I'm using namespace std and so on. And here I define inside my main function this integer h. I give it the value 5, and then I'm using h++. So if I do that, and then I use cout h and cout m to see what happened to h and m. Here I see that if I print h, it actually still has the value 5. Which is this line here. So I'm sorry. Actually, that's not what happened. So I confused myself. Let's go back one slide. So we said that the postfix operators k plus plus, k minus minus, they change the value but make use of the initial value. So this is exactly what happens here. So if I use m equals h plus plus, that will make use of the initial value, which was 5. And that's what is being printed here. It's printing the initial value of h. But h is changing its value. So h increases by 1. So although I initialized h to be 5, if I try to print h, I get the value 6. On the other hand, if I define a different variable k, let's pick it to be 5 again, and then I use plus plus k, then that will increase the value of k and use the new value. So if I print k and n, they're both going to be 6. So again, the postfix operators, they change the value but make use of the initial value. This is what happened here. Whereas the prefix operators, plus plus k or minus minus k, they change the value and then make use of the updated value. Okay. Besides plus plus and minus minus, there are other unary operators for changing a single variable. For example, plus equals, minus equals, star equals, and divided by equals. For example, if I introduce an integer k equals 5 and I say k plus equals 3, that is the same as saying k equals k plus 3. And if I say k minus equals 2, that's the same as saying k equals k minus 2. So the first command adds 3 to whatever k is, and the second command subtracts 2 from whatever k is. Similarly, you can divide by a number. So if I define a double x that's equal to 3.4, this command will multiply x by 2.4 and set that result equal to x. And here, this command slash equals, this will divide x by 3.5, and then it will set that result equal to the new value of x. The following pieces of code are equivalent. So if I have k, the plus equals 3, it's the same as saying k is k plus 3. So that takes k, adds 3 to it, and sets that equal to the new value of k. So k becomes 8. The single equals that we have already used is the assignment operator. So that sets a number equal to another, or it sets a variable equal to another variable. If I want to test whether an equality is true, or if I want to solve an equation, for example, that can be done by using the equals sign, or the equals operator. So here I have int m equals 4 and integer n equals 3 plus 2, and then I want to check if m equals 1. I can define a boolean variable b that is equal to m equals n. So that is a test. So m equals n is asking, is m equal to n? And the result is going to be true or false. So the Boolean variable is going to map false to 0 and true to 1. So this Boolean variable b will either be 0 or 1, basically. In this case, m is 4 and n is 5, so this is false. So this Boolean variable b is going to be false, so it's going to be 0. So if I type cout b, I should get 0. So you can try this, type up this program in a C++ file and run it and see what you get. Another way to compare values is to check if something is lower than or greater than, or lower or equal, or greater or equal. You can do that using these operators. So like equals equals, these return a bool value. So in this case, for example, I can define h to be 4 and k to be 5. And then I can ask, is h lower or equal to k? And this is actually true. So 4 is lower or equal to 5. So if I run this, it should return true, or in this case, 1. So try and run this code and see what happens. Some other operators that can be used to combine different statements are this ampersand, this AND operator, this is the OR operator, and then this exclamation mark can be used to denote the NOT operator, and exclamation mark followed by equals means not equal. So each of those is a single operator. In some languages you can use a single symbol like this one or this one to denote the AND and OR. But these have different meaning in C++, so we are not going to need them. We're going to use the double symbols in this case. We may see this later when we discuss pointers, but for now we don't need it. Okay, you can find rules for operator precedence given in this link below. We haven't mentioned any of these operators, many of these operators yet. But as with simple arithmetic operators, you can use round brackets to make the precedence more clear. You can also split statements into more than one line to make the precedence more clear. And remember that the AND operator has higher precedence than the OR operator. You can look at the book by Schild, pages 59 to 74. That's going to be linked below for more on data types and operators. And I will finish with a few remarks about C compilers and IDEs. There is a version of Visual Studio that you can use for Windows. It is free for personal or educational use. It's called Visual Studio Community Edition and has all the important features that the paid-for versions have. So this is a full IDE that's known as an integrated development environment. You can find the most recent version in this link, visualstudiomicrosoft.com. The students also have access to a professional paid-for version of Visual Studio Enterprise Edition. You can go to Azure for Education or Microsoft and log in with your university credentials, and you will have access to certain software and enterprise level software. Now, C++ are not tied to specific software such as Visual Studio, of course. There are many other IDEs. For example, you can use CLion or Eclipse, NetBeans, and so on. The advantage of these is that they're available in all operating systems from Windows to Linux to macOS. One potential issue is that sometimes you need to have a separate compiler. So for example, in macOS, if you install Eclipse or NetBeans, you need to have a separate compiler. So that complicates the installation a little bit. And in Windows, if you install CLion, you need to install some other compiler like Visual Studio or something else, so that CLion can call that other compiler and use it. Or you can write code in a text editor and then compile it separately. The way to do this is going to be described in the notes that I will post. Or you can simply go online and search for an online C compiler, such as the website cpp.sh. And in Linux, you can, of course, use GCC and G++. For Mac, you can use Xcode, which is what I used earlier. You can also use CLion, which we'll also use in other lectures. The problem with Visual Studio for Mac is that it is for C# and F#, but it doesn't support C++. So you could use Visual Studio Code possibly for Mac, and there are ways to use C++ with Visual Studio Code, but you have to do some more involved installation to make that work. And a lot of information on these environments and on C++ can be found on the Stack Overflow and another Stack Overflow page that I will link. And if you're using Windows, then when you install Visual Studio Community Edition, there will be an option which workloads you want to install, and the best option to pick is desktop development with C++. If you pick that, then there's no need to customize the other options, like individual components and language packs. This will select the necessary material to install for you. And this is it for this video. Thank you for watching.